So all of these one-way between group ANOVAs basically are the same. You just replace the variables. So DV is cognitive test scores, continuous variable. Dosage strength sounds like a grouping variable to me. Jumping over to SPSS. Right, dosage strength, and we've got 4 different subgroups, levels of the IV called dosage strength, and cognitive test scores. They do look like they're in scale. Okay, we're ready, Freddy. Again, we're going to check the normality first. Descriptives, explore, out with you. Get back out of there. Boom. And cognitive test scores. And again, this is the one we want. Normality plots with the tests. Click continue. So we're going to look at the Kolmogorov-Smirnov test, and it was not significant. Therefore, it did not violate the assumption of normality. And again, the histogram, that does look kind of normal to me. Not perfect, but close enough. So we're going to run the test. Analyze general linear model univariate. Out with you guys. Cognitive test scores is the DV, dosage strength. Everything else here should be picked already. Let's make sure the post hoc test, Tukey. And options, right, descriptives, estimates of effect size, power, and homogeneity. That's us. Good to go. Click OK. All right, step 1. Here is the number in each group. Very important. These don't have to be the same number in each group, okay? This is just, made up data. But here's the means. So I got a high of 7.3 and a low of 5.8, 5.7, so it's about 1.6. Square root, I'm going to say, yeah, there is a significant difference in there. Levine's test, where are you? Right there. Boom. Did not violate the assumption of homogeneity variance. So in other words, the variance of the cognitive scores is relatively the same across all 4 of the different drug values there. And here is our F test. So we can explain 11 times the variance of the cognitive scores based on the drug group, which is a lot. And it is significant, big time. And we have a huge effect size, 0.626. So in other words, we can explain about 63% of the variance in the cognitive scores because of the grouping model. And our power is practically perfect, which means we're good to go. Let's see what else we got here. Tukey test, Tukey. And again, I just looked down. Oh, my gosh. So the placebo is significantly different in all 3. I think that's basically all we need to know, right? And let's just make sure, yeah, it's the placebo versus all 3. So that is it in a nutshell. Hold on. A one-way between group ANOVA indicated that there was a significant difference in the cognitive test scores between the 4 different drug levels. F, 3 degrees of freedom between group, 20 degrees of freedom within group, or the error group, equals 11.17. That's huge. Let's just double check that. There it is right there. Which means that 11 times of the variance is coming from between the groups than within the groups, which is proof that the difference in the cognitive scores is coming from the grouping. So in other words, the drug seems to be working better at making these guys have higher cognitive test scores. Must have been invented by a math teacher. Effect size really huge, 62.6%. With a power of 0.996. Again, that has to be over 0.8. It has to do with your sample size and other things. And the Tukey test showed that there was basically a significant difference between the placebo and all 3 of the drug dosages. And there's the means. You can check them yourself. And the normality and homogeneity variance were not violated. So that's it. MGZ out.